Hello, everyone. Welcome to DriveScale. It's Tech Field Day 17, I guess. And we're so happy to have you here. It's a lot of fun for everyone involved. So, my name is Tom Lyon. I'm co-founder and chief scientist here. And I've been around the Valley for 40 years now, my fifth startup. So my chief value is in having opinions. So I have opinions and I'm not afraid to use them. And everything you hear me say should be taken as opinion or observation, but certainly not fact. And that's my Twitter handle there. So I'm going to talk a little bit about data center trends, and then I'm going to go into a longer story. But this year has had quite an enormous amount of hardware innovation. And here at DriveScale, we're very close to hardware, even though we're a software company. And so we pay a lot of attention to the hardware trends. We see 25 gig, 100 gig Ethernet is pretty much everywhere. All new racks going in should be on at least 25 gig. It just makes no sense to have anything slower anymore. In the CPU space, AMD is back with a vengeance with their EPYC processor. And Intel is having big problems. They're having problems with production and with their next generation fab. So AMD's got quite a good window going on. And AMD is kind of making the single socket server space sexy again because they have so much crammed on a single socket. 3D flash is now crushing the dollars per terabyte for SSDs. Enormous drop in prices this year, and that's going to continue for a while. But at the same time, the minimum size of a SSD is kind of skyrocketing. Satya, my co-founder, showed me the other day, they're starting production of a 96-layer 3D flash chip. Each layer, 64 gigabits. That means the one package is 6 terabits. That one package still only has an 8-bit bus going to it. So if you want performance, you got to go wide, have 16 of those. You're at a 12 terabyte minimum SSD to get the performance you want. But the dollars per terabyte or gigabyte or whatever are going to be really cheap. So it makes it really interesting to see how you're going to leverage SSDs going forward. At the same time, we've seen SSD prices dipping near about 30 cents a gigabyte and hard drive prices going below 4 cents a gigabyte. So the classic 10-to-1 ratio of hard disk to flash has gone below 10. And that's very good news for flash. DRAM prices have gone way up this year. DRAM is highly cyclical, of course, but some of it is the big vendors like Samsung and Hynix invested more in flash than DRAM. So DRAM's gone way up. NVIDIA, of course, is dominating the AI world, printing money with their Tesla GPUs. That's really amazing to see how well they're doing and how incredible the AI scene has been. And then FPGAs are getting exciting. Intel came out with standard product FPGA boards, and Xilinx just last week announced standard product FPGA boards. What's interesting there is it brings a disaggregation model to the FPGA world, where now the guy who provides the logic and the software can just provide it for a standard hardware product. You don't have to build your own hardware that uses an FPGA, that uses your logic, that uses your software. So things are going horizontal. And we talk a lot about disaggregation here. But I always like to point out the most important form of disaggregation in the data center is the separation of server from hardware, or hardware from software for servers. And that's what's enabled things like VMware and Linux to get a foothold and grow. In the desktop space, I bought a new little desktop for home this summer. I still couldn't buy one without Windows bundled into it. Really annoying. So it's not quite disaggregated on the desktop. Somebody pointed out there's 90 different machine learning chip startups. Of course, they're not all going to be successful. We know of one where they're doing 4,096 RISC cores on a single chip. Just insane. And then persistent memory has all been a very exciting topic over the past 7 years. And I figured out why they call it persistent. They keep talking about it. And nothing happens. And the big news yesterday or the day before about Micron buying their half of the fab from Intel. And it's the fab that produces 3D XPoint. So maybe that's just a simple financial transaction, or maybe that's Intel declaring it's over. So we won't know for another year or so. All right, that's enough with these pseudo facts. Now we're going to go really into opinions. Talk about what intelligence means to the storage world, but really to all the new disaggregated devices coming around in the data center. So in the good old days, before intelligence, we had relatively simple devices. Everyone knows what we have on the left here, the rotary phone. And it's actually not that simple either, because before that there was the phone without a rotary. It's the rotary that enabled the whole automated call setup throughout the world. But this simple, stupid, thinnest of thin clients set the standard for a protocol which exists today, right? So if you had one of these and you had a landline, it would still work. And of course it interoperates with everything today. So the protocol it's set is ubiquitous and standard. Here we have the Fujitsu M2351, the incredibly reliable and popular hard drive from the early 80s. And this sucker could survive anything. And it was OEM'd by Sun. I had a lot of hands-on time with that. And OEM'd by Digital and Amdahl and everybody. And it was really built for the mainframe world. And they didn't pay much attention to ease of use, configurability, that kind of thing. But hard drives like this also set a standard, which is ubiquitous today. And it wasn't this one, but earlier mini computer drives set the standard for 512-byte blocks and simple read and write. And that's everywhere today. Getting over that has been difficult, even to go to 4K blocks, right? That's still a transition that hasn't quite happened. And so the protocols that these things set are very long-lived and very hard to get around. Back to the ease of use question, to change the unit ID, if you had two of these on the same controller, you had to pop the lid off, pull the board out, and change the little blue jumpers on the board, put it back in. But they were built for reliability, right? So those boards, you couldn't get them out by hand at all. And just to show well, of course, if there was a special tool you needed to get the boards out. And of course, if you're a geek dealing with those all the time, you had to have your own special tool. And to show you what a geek I am, I have my own special tool still. And I found this when I'm organizing my junk. And upon further organization of my junk, I found another one. So this one is for Steve. Your very own Eagle tool.
That's great.
That's awesome.
Wow. Representative of how not to do configurability.
Right.
Speaking of crazy tools, by the way, I have in my wallet the wrench that came with the EMC Clarion.
Wow.
And I've been carrying that for 25 years.
Oh.
Very
So
cool.
if anyone ever complains about you keeping weird tools, you can tell them that it's okay.
Brother from another mother.
Someday we'll be passing down our sim popping things from Apple.
Right. All right. So time goes by, and now there's the digital awakening, right? And this still wasn't really digital, but it had a transistor in it. In fact, the touch phone had one transistor that they managed to get simultaneous two tones out of. I never understood. In the disk space, I forgot to mention back on this bad boy. This is really, really dumb, and it needed a controller to do anything useful. And then, of course, the host had to talk to the controller to the disk. Got to the PC space, people started trying to integrate the controller logic with the hard drive. So this is the old hard card from the PC world. and really it begins the march of intelligence towards the storage. Many years pass, and now we're into the heyday of the cell phone. I was at Nokia in year 2000 when they were the most valuable company in Europe, and it was a great party until it all fell apart. And of course, to implement a phone, which is clearly still a phone, there were millions of transistors and millions of lines of software, and it's really a very intelligent device. But as far as programmability went, there was none. Once it was built to be an appliance. And, it had a game, it had Snake. It had a calculator, right? So it had like 2 apps at least.
A lot of apps.
Back in the storage world, SSDs were coming around. And the earliest SSDs were really very dumb as well, but started to hit this flash translation layer problem of you needed to deal with flash wearing out and all that kind of stuff. So intelligence began to creep into the actual drive. But of course, they're still trying very hard to emulate a disk, just like that's trying very hard to emulate a phone. Then the world blew up with the iPhone. The major hardware innovation on the iPhone was the multi-touch screen, right? Really cool. You could swipe and gesture and all that good stuff. And of course, it took another zillion lines of software to support that in some useful way. And it became so intelligent and so useful that it could be extended in interesting ways. Back in the storage world, we have the Fusion IO SSD. And it was like the first storage device that doesn't look like a disk anymore. And it's very interesting because the hardware was really quite simple. That was the innovation, to simplify the hardware. But the host had to do all the work of the intelligence, for which there's another huge amount of code. And so this caused the whole storage industry, the whole SSD industry to wake up and say, we're going to need a whole lot more intelligence in the SSDs because the host doesn't really want to have to do that work. And so the big innovation of the iPhone, of course, was apps. And this is where the world went crazy with innovation and whatever. And so what's going to happen with storage? And I think this computational storage is a very interesting area to watch. I know Enrico has written about this some. Last time we were here, I think we talked about the interposer. This is the little interposer that Marvell made to add intelligence in front of a hard drive. So lots of interesting stuff there. But before we talk about it more, let's talk about NVMe. So NVMe Express, another standards protocol. It is just a protocol. It's finally a pretty intelligent protocol. You can do fast, wide, deep queues, and things don't get in your way very much. But it's still basically a disk, block read-write semantics, with a bunch of other features crawling in. And so like any other standards committee, the prime directive is to always have more work to do. Right? So there's mushrooming complexity in the standard. There's option after option after option. And it's getting very, very scary about the amount of firmware we have. And I claim today one SSD has more firmware than an entire SAN system did 10 years ago. Because it's already doing RAID, it's doing error correction, it's doing namespaces, which are like LUNs and yada, yada, yada. And it's getting worse in a hurry. And so that leads to some trouble in that what the hardware giveth, the software taketh away. Or like they used to say, what Andy giveth, Bill taketh away. Andy Grove from Intel, Bill. In many cases, all that firmware really gets in the way of the possible performance. And so now we have very interesting things going on in the industry. We have the open channel SSD camp that says, well, let's do like Fusion IO and get a lot of the firmware out of the device back into the host, and then we can optimize layers between the host and the SSD and do things a lot better. At the same time, we have Samsung promoting the key value SSD. And of course, Seagate did the key value drive with a Kinetic. And basically, let's move some of that app into the device so we can better integrate the key value layer with the device layers. So these are both perfectly valid approaches. This one is more about, let's create a new standard. This one is more about, let's allow interesting applications. And what's really interesting is all three models, the normal, light, and heavy, it's all exactly the same hardware. And I verified this with one of the Samsung designers of this thing. They took exactly the same hardware, changed the firmware. So NVMe over Fabrics, another great thing that's happening. Unfortunately, Fabric tends to imply a tightly controlled environment, and enterprise Ethernets are just not like that very much.
Need that slide.
Yeah, it's beautiful.
And so today, everything is NVMe on RDMA. RDMA really only works in a pretty homogeneous environment. But fortunately, the NVMe over TCP standard, the technical work has been finalized. It's not published yet, but this will hit the streets next year and make it, almost fast enough NVMe very, very widespread. And of course, all these other things that happen in the NVMe context will be available over the fabric as well. Now, unfortunately, NVMe had this really great feature in that it got rid of the controller between the host and the device. It's straight PCI Express, very wonderful, and that's a fundamental cost savings inside the server. No more SAS or SATA controller. Of course, NVMe over Fabrics now requires a new kind of controller to go from the fabric to the device. So that controller is a significant cost. And most people today, including us, are doing this with some kind of x86. But there's a huge amount of innovation and competition for the future of that kind of controller. Broadcom and Mellanox are heavily marketing chips to do that kind of thing. There's several startups. In the software space, Toshiba's promoting this QMO-scale approach as a kind of a software controller for NVMe drives. But I think the best kind of controller is no controller. And this is where it's very, very interesting to see Western Digital announcing their OpenFlex composable products, where basically it's an entire rack-mountable box that lives on the fabric. If you crack open the box today, yeah, there's still NVMe drives in there. But in the second generation, you don't get to crack open the box. It's just a new kind of storage platform. And they can integrate more between the fabric and the device. And WD is a great partner of ours. We work with their JBOS, we work with their Flash box, and we're going to work with OpenFlex. Back on computational storage, there's an academic faction that calls it U-social storage. Has anyone heard that term here? Yeah, it's kind of strange, but I went to a conference at UC Santa Cruz and they had 5 presentations about this. So basically, there's intelligence in the device. And really, the big payoff is if you can move compute to the storage, which has been the holy grail for many years. This is what Teradata did in the 80s. It's what NetTeasa did in the 90s. It's what Hadoop did, with Yahoo and Hadoop.
Yeah.
And it's a big payoff for some class of applications. You can leverage parallelism. NGD Systems is a startup. They're either have or are going to have a 4-core ARM64 running Linux on an SSD device. And they can do this because the cost of adding CPU cores to a chip is very close to 0 these days. And you had to have the chip anyway to be an SSD controller. Interesting, though, is that it still lives on NVMe. The very first layer of software they had to provide was Ethernet emulation, so they could talk to the Linux inside the thing. So you can see where integrating that with the fabric could be a payoff. ScaleFlux is doing similar things, but with programmable FPGA on the SSD. So that's pretty cool. But the incumbent storage device and storage system vendor that whole industry, they're not into apps. They're afraid of apps. And this is a perfectly natural engineering style reaction to like, they want to do what with my product? And people just don't get it. They either get it culturally or they don't, and it's a big leap. And I was at Nokia before the iPhone, and the best way to get Nokia to do something was to go create a standard. And so I think there's a potential that the storage industry changes as much as the mobile phone industry changed when we get around to computational storage and the real promises of apps. So the challenge for the industry is, where do standards stop and where do apps begin? And this is my favorite Dilbert ever. Yeah, of course, it conforms to all the standards, but what does it do?
X500, for example.
Yeah. So I'm more of a networking guy historically, but I think really it's all about communication. Today's phones are really all about communication, but they speak thousands of protocols, right? Unless you're using them for just a game, but usually the game is against somebody else or a scoreboard or something. It's still communicating. And I think programmability is really fundamental to optimizing communication. And so the iPhone, et cetera, are a huge example of all that. And now the Internet of Things is coming around where you just take the human out of the equation, but there's still a huge amount of communication and programmability that are enabling this new industry. So Internet of Things is hot. Drives are things too. So let's make drives and/or controllers, which is a step towards the drive, great at communicating. Let's make them programmable. Let's make them very agile. Put them on the fabric, et cetera, et cetera. And of course it will be based on Linux. It'll probably be based on Kubernetes. And it'll be very cool. At the end of the day, though, it's still storage. And you're going to be doing storagey things in the storage, and you're going to be doing heavy compute on the server. And it's not going to replace a server. Although there are a lot of servers in the world. I like to call them protocol droids, because it's like they talk to this guy and say, okay, and then they turn around and talk to that guy. And nothing changes but the protocol. So if you could move the protocol to the next step, put some programmability over there, you eliminate the middleman. So communication is the problem. Bill Joy had this great quote, 99% of commercial computing is just moving stuff around. Texas Advanced Computer Center tells their users computation is often cheaper than communication. Think about how you write your programs. And of course, 10cc said communication is the problem to the answer. Who knows 10cc? Tell me I'm not that old. But and notice the similarity of the logos. All right, but what about disaggregation, composability? We're all about disaggregation. So this computational storage sounds a lot like reaggregating instead of disaggregating. But getting the device out of a server is the first step in disaggregation. You have to add intelligence to do that. Today we're doing it with storage. Tomorrow we're going to be doing it with accelerators. Someday DRAM. And every liberated device will have some amount of compute, storage, and networking, but it's going to be drastically different depending on the type of device. And composability is all about assembling these devices to do something interesting. So that's what we do. We make compute infrastructure adaptable and programmable. So you don't need those anymore.